This video is about the division properties of exponents. So we're going to simplify using the laws of exponents. So the quotient of a power, to divide powers that have the same base, we are going to subtract the exponents. So now our base is going to have 1 in the denominator and 1 in the numerator, so we're going to subtract our bases. If the base of the higher exponent is in the numerator, then we're going to subtract and leave our simplified into the numerator. And if the larger exponent's in the denominator, we're going to subtract and leave the simplified in the denominator. So let's simplify the following. Number 1, g to the 19 over g to the 12. 19 is the larger number, so we're going to bring this 12 up to the numerator. So g to the 19 minus 12. You can put over 1 if you want, but you don't need to. This gets us g to the 7th. Number 2, 5 to the 7a over 5 to the 13a. 13a is larger, which means we're going to go into the denominator this time. So 1 over 5 to the 13a minus 7a gets us 1 over 5 to the 6a. Number 3, now there's two bases. There's a d and an f, so they're going to be treated separately. So for d, we have d to the 9th and d to the 12th. The 12th is larger, so d is going to go to the denominator, 12 minus 9. F, we have f to the 30th and f to the 5th. 30 is larger, so in the numerator, we're going to have f to the 30 minus 5. And then we can subtract, and we get f to the 25th over d to the 3rd. Number 4, same idea. We have a and b. A to the 9x over a to the 3x. 9x is larger, so a is going to go into the numerator. So a to the 9x minus 3x. B to the 10x is in the numerator, and b to the 10y. B to the 17y is in the denominator, which is larger. So b to the 17y minus 10y. When I simplify, I'm left with a x to the 6th over b to the 7y. Now, number 10, we're going to do the same thing, subtracting our exponents, but notice we have these numbers. So when there's numbers in the numerator and the denominator, we're going to reduce them if possible. So 10 over 20, I can take a 10 out of both numbers. That reduces to 1/2. Then I look at the v. I have v to the 9k over v to the k. Well, 9k is larger. So in the numerator, 9k minus k. Remember, k is really 1k. So I'm going to be left with v to the 8k over 2. You can put a 1 in the numerator if you want, but it's not necessary. Number 6, look at 8 and 12. I can take a 4 out of both to reduce. So that leaves me with 2 over 3. When I look at the m to the 15th is larger, so in my denominator, I'm going to do 15 minus 9. When I look at q, remember if there's no exponent, that's a 1. So 20 is larger, so again in the denominator, 20 minus 1. So this reduces to 2 over 3m to the 6th, q to the 19th. The other property we're going to look at is product of a quotient. So with a product of the quotient, we have a fraction, and we multiply the exponent to the numerator and to the denominator. So this is not much different than when we had a power of a product. We're still going to take our exponent, we're going to multiply to both things. So here this is a 7 to the 1st. So I'm going to multiply to the numerator and to the denominator, and then simplify if necessary. So number 1, I'm going to multiply 3 to the 9 times 3 over 8 to the 3 times 3, which gives me 3 to the 27 over 8 to the 9th. I'm not going to worry about using exponents with those numbers because I know it's going to turn out to be larger than 4 digits. Number 2, we have h2 over g to the 4th all to the 9p power. So I have h to the 2 times 9p, g to the 4 times 9p, and that multiplies out to h to the 18p, g to the 36p. Number 3, this is where we got to be careful again. Make sure that this 5 is also getting the exponent. So when I multiply this, or when I use my exponent, I get 5 to the negative 10th, v to the 3 times negative 10, and w to the 9 times negative 10. Notice, though, when I multiply, all of these have negative exponents. I'm not allowed to have negative exponents, so I need to move everything. So anything that has a negative exponent has to move. So this and this need to move to the denominator, and this needs to move to the numerator. So when I simplify, then I get w to the 90 over 5 to the 10th, v to the 30th. Remember, exponents only become positive if you move them from one part of the fraction to the other. Number 4, we have a 5 exponent that needs to go to each term inside the parenthesis. So we get 7 to the 5th, f to the 2x times 5, g to the 3y times 5, all over 9 to the 5th, f to the 4x times 5. So I'm just going to leave 7 to the 5th because if I put that into a calculator, it's bigger than 4 digits. So I'm going to say 7 to the 5th, f to the 10x, g to the 15y. Same thing with 9 to the 5th. I'm just going to leave it as an exponent, f to the 20x. Now notice here, I have two f's. I have an f in the numerator and an f in the denominator, so I need to subtract those exponents. Now, f to the 20th is larger, so it's going to end up in my denominator. So I would have 7 to the 5th, g to the 15y, all over 9 to the 5th, and then when I subtract 20x minus 10x, I get f to the 10x in the denominator. Number 5, I'm going to multiply all of my exponents by negative 2. 3 to the negative 2, r to the 8 times negative 2, x to the 3 times negative 2, all over 6 to the negative 2, x to the 9 times negative 2. So when I multiply my exponents, I notice that they're all negatives. Which means that they need to change the level of the fraction they're on. So everything in the numerator is going to have to move to the denominator. Everything in the denominator needs to move to the numerator. So that gets us 6 squared x to the 18th over 3 squared r to the 16th x to the 6th. Now, I can multiply out using my exponents 6 squared and 3 squared, which gets me 36 in the numerator and 9 in the denominator. Also, I have two x's, so I can subtract those exponents, which gives me x to the 12th, and that goes in the numerator because 18 was bigger, r to the 16th. Now, 9 and 36 reduce, they're both divisible by 9, so that leaves me 4x to the 12th over r to the 16th. If you want to put a 1 in the denominator, you can, but it's not necessary. Number 6. I'm going to multiply all of my exponents. So I get 7 to the 6 times 4, y to the 5 times 4, z to the 7 times 4, all over 5 to the 4 times 4, y to the 8 times 4, z to the 3 times 4. So when I multiply, I get 7 to the 24th, y to the 20th, z to the 28th, all over 5 to the 16, y to the 32nd, and z to the 12th. Now notice I have a y in my numerator and denominator, and a z in my numerator and denominator. So those need to be subtracted. So 7 to the 24th and 5 to the 16th stay still in the same place. Y 32 is larger, so when I subtract, I get y to the 12th in the denominator. Z, 28 is larger, so when I subtract, I get 16 in the numerator. So let's put it all together now. So number one, first thing I need to do is multiply my exponents. 2 to the 6 times negative 3 over 2 to the 12 times negative 3. That gets me 2 to the negative 18 over 2 to the negative 36. Both of my exponents are negative, so they need to switch parts of the fraction. So the numerator goes to the denominator goes to the numerator. 2 to the 36 over 2 to the 18. These are both the same exponents. They're both 2's, so I'm going to subtract. 36 is my larger exponent. So in the numerator, 2 to the 36 minus 18, which becomes, when I subtract, 2 to the 18th. Number 2, there's a negative p exponent, so I'm going to do the same thing again. I'm going to distribute my exponent. And when I multiply, I get a to the negative 8p and a to the negative 40p. Now, both of them are negative exponents, so the numerator needs to switch to the denominator and vice versa. So I'm left with a to the 40p over a to the 8p. 40p is larger, so when I subtract my exponents, a to the 40p minus 8p, we get a to the 32nd p. Number 3, now we're bringing some multiplication property first. If I have letters that are on the same level of my fraction, or same bases on the level of my fraction, remember that I'm going to add my exponents. So h to the 17 plus 20 over h to the 35th. So when I add those together, that gets me 37. And then I'm going to subtract my exponents. 37 is larger, so h to the 37 minus 35 gets us h squared in the numerator. Remember, if it goes to the numerator, you don't have to include the 1 on the bottom if you don't want to. Number 4, so we have negative exponents that have to move. C in the numerator, C in the denominator, X in the denominator. And while I'm at it, I'm going to reduce 7 over 49. So 7 over 49, I can take a 7 out of both, which leaves me with just a 7 in the denominator. X to the 20th in the numerator, X to the 5th in the numerator, C to the 45th in the numerator. Remember, order doesn't matter. And in the denominator, I just have 7. And C to the 10th. Now, notice that there's 2 x's in the numerator. So if there's 2 x's in the numerator, I'm going to add those together. So if they're in the same part of the fraction, we're always adding our exponents. So we x to the 20th plus 5. Notice that C, one's in the numerator and one's in the denominator. So now we're going to subtract. The numerator has the larger exponent, and 7's just going to stay on the bottom. So when I simplify this then, I get x to the 25th, c to the 35th, all over 7. Number 5, so I have 2 a's in the denominator that can get added together, which leaves me with 4a to the 8m over 8a to the 14m. Notice that we have 2 m's, one in the numerator and one in the denominator, and we can reduce 4 and 8. So to reduce 4 and 8, both numbers are divisible by 4, which leaves us 1 over 2. For the m's, I'm going to subtract them, so 14m is larger. 14 minus 8 gets us a to the 6m. So the 1 is needed in the numerator because I need some value in there since everything else has either been divided out or moved away. Number 16, a to the 8r times ar to the 15th over a to the 9r. So first I'm going to subtract my exponents. 15 is larger, which leaves me with a to the 8r times a to the 6r. Now I have a's with exponents that are in the same part of a fraction because there's no denominator, so I'm going to add those together. So 8 plus 6 is 14r. Number 7. Notice in number 7 there is a 0 exponent, so I'm going to deal with that first. When I have a 0 exponent, that just becomes 1. So that leaves me with -2, and I'm going to distribute my exponent. So everything's going to get multiplied by x. So -2 times, and then my other fraction, a to the -2x, d to the -4x, a to the -9x, d to the -5x. Now, I can multiply 2 with the fraction if I put 2 over 1, which means that 2 just becomes part of the numerator and 1 just becomes part of the denominator. These also have negative exponents, so they need to switch their location in the fraction. -2 does not switch, though, because -2 is a negative number, not a negative exponent. -2a to the 7x. D, 5x is larger again, so 5x minus 4x gets us d to the x. And this is my final answer. Number 8, we need to distribute an exponent of 2 everywhere. So this becomes 3 squared a to the 16x, c to the 2x, all over 6 squared a to the 2x, c to the 18y. So I can use my exponents to simplify these numbers. So 3 squared is 9, and 6 squared is 36. Now, when I go to simplify this, I can reduce 9 over 36 to 1 over 4. And I'm going to subtract my a exponent. 16x is larger, so I don't need the 1 here since I know a is going to stay in the numerator. 16x minus 2x gets us 14x. 18y minus 2y gets us 16y in the denominator. Last one, number 9. I can reduce -2 or -4 and 2 to just -2 in the numerator. I don't need a 1 in the denominator. I'm going to move anything that has a negative exponent. So x, y, y, and x are going to switch parts of the fraction. So I'm left with -2 x to the 8th, y to the 3rd, over x squared y to the 10th. So when I subtract my exponents, the x's subtracted leave us -2 x to the 6th. And when I subtract my y exponents, 10 is larger, so y to the 7th in the denominator.